Hey, what up, guys? I'm pretty sure my man Frank already explained to you the functions of this little structure and how it's formed like this. Today I'm about to learn you these tables right here and how to fill them up. We're here to discuss the hybrid orbital, number of sigma and pi bonds, molecular geometry, and bond angles of the various carbons that are found in this chemical. We don't count the hydrogen because hydrogens are, or we don't include those. um for the hybrid orbital of the first one, remember that in order to find the hybrid orbital, you need to find the number of electron domains in each chemical. So in this case, for each, not chemical, element. In this case, the first carbon has one, two, three, four electron domains. So that automatically gives it hybrid orbital of sp3. Um, in mind that as the number of electron domains increases, in terms from if it has two electron domains, it has a hybridization of sp. If it has three, it has an hybridization of sp2, and if it has four, it has a hybridization of sp3, in which we use that example. For number five, it turns into sp3 plus, and so on and so forth. Um, so Next is the number of sigma and pi bonds. So in order to find this is actually really really simple. Um, so keep in mind that we're here to count the single bonds, the double bonds, and the triple bonds, or to find these sigma and pi bonds. So um, keep in mind these rules that for every single bond and double bond and triple bond, there is I'm gonna tell you how much sigma and pi bonds there are. So there is let's just write it down. So for every single bond there is one sigma and zero pi bonds. For every double bond it has for the double bond it's one sigma and one pi bond, and for triple bond it's one sigma and two pi bonds. You can see like only the pi bonds increases for every single uh, added bond in the structure. In this case, the number of sigma and pi bonds for this one is, let's count the electron domains associated with this element. So it's one, two, three, four single bonds, which means it has four sigma bonds, and as you can see there's no double or triple bond surrounding it, so it's zero pi bonds. So next is the molecular geometry of this carbon. So keep in mind that the molecular geometry varies with the number of lone pairs that each element has in the structure. Which in this case there's no lone pairs, so that automatically gives us um, the idea that the molecular geometry of the first carbon is tetrahedral. And with tetrahedral gives us a bond angle of 100 and 109.5. And now let's move on to the second and third carbons, in which I already discussed these rules, so we should be getting to them pretty quickly. For the hybrid orbital of this, um, Uh, so you can see that for the second one we have a triple bond in this second carbon. So as you can see, there's no extra valence electrons around it, so that makes it so the lines here indicates that it has four electron domains, same as the first one. So its hybrid orbital is going to be sp3. Now next is the number of sigma and pi bonds. As you can notice, as I discussed earlier, this already has a triple bond and a single bond. So a triple bond means, if we would look at these rules above that I wrote, one triple bond is equal to one sigma bond, one sigma bond, and two pi bonds. So let's count our bonds. So it's one single bond and one triple bond. So that automatically makes it one single bond, one plus one triple bond, which is two. So it's two sigma bonds and two pi bonds because it has a triple bond. Now the molecular geometry of this one is so let's see, there is no lone pairs anywhere basically in this structure. So that automatically it gives us the idea that well, it's the same as the first one. So if it has zero lone pairs and it has four electron domains, its molecular geometry automatically tetrahedral with the same bond angle of 109.5 degrees. Now the final one, as you can see, like the final one kind of looks like the second one, in which as you can see, I mean, there's no lone pairs, no extra valence electrons. So as you can see, it's pretty much the same as the second one. So hybrid orbital, it's like 1, 2, 3, 4. So that gives it as a hybrid orbital sp3. It has one triple bond and one single bond like the second one, so that gives us 1 plus 1, 2 sigma bonds, and 2 pi bonds. Now there's no lone pairs in this one, so that gives us a molecular geometry of tetrahedral with a bond angle of 109.5 degrees. As you can see, as you cannot see because my lights turned off, oh, wait, oops. As you can see,